Okay, hello everyone. Welcome to the June 17th Monday edition, earlier morning edition for those on the Pacific Coast of the Carpenter Working Group. As usual, we have the Carpenter Working Group blog that's posted into the chat. So if you've got any additional questions or RFCs or things you'd like us to discuss, feel free to throw those in there. I'm going to go ahead and share my screen and reference that, and then we can go ahead and start looking at the agenda. If I can find the page. Sec. Find the right window. Okay. So in terms of product updates, I think last time, if you didn't attend last time, we had released V037. I believe there were, take a look over there, just because I need to refresh my own memory on what went with that release. I guess we had a few updates to the clock provider. We did have a couple bug fixes within that release. Some minor things. I think we were kind of staging out some things related to waiting on instance terminations. So there's some changes that are going to come on this upcoming release in V038, which should include things like waiting on the instance to be fully terminated before we remove the node claim and the node from the cluster, which should help with a few different things we've had to handle as a result of terminate the node early. One of those things including like handling lease garbage collection and cleanup, which we should be able to get rid of now. I think that change was just merged, so that should come in the next release. So we were making some changes there. I believe over in the AWS provider, a couple things on EBS maximum bandwidth. We had added some additional things to the bottle rocket config. I know that with the bottle rocket config, there's some ask for we basically statically define it within the Karpenter code base, and there's some room for change there in terms of perhaps just making it more dynamic so that we don't have to keep making changes into the code base every time the bottle rocket introduces a new config parameter that gets merged into the user data. So I believe there's an open issue for that. If you're interested in helping with that, feel free to open a PR. Some bug fixes, and I think we had introduced a readiness condition of these two node class, which is kind of staging out some of the work that we're going to do as part of V1. And that's within the V1 proposal that includes adding a bunch of status conditions into the EC2 node class. We already have status conditions in the node claim, basically relying on those readiness on those objects as well as readiness in the node pool to dictate whether we can provision with the node pool. So that allows us to do some things like know that CI, or I guess the infrastructure resources are up ahead of us doing any provisioning, which is currently a problem right now when it comes to like our node pool is a little bit blind to the EC2 node class it's referencing, at least with respect to like whether the instance profile is stood up or whether it has permission, or I guess whether it has like security groups provisioned for it or AMIs resolved for it. So those changes are coming in V1. That should help with some things around the efficiency of us provisioning so that we're not launching things and then realizing that we can't then provision with them. So that was V037. The other thing I wanted to call out, and I think Nick is here, so I don't know if you wanted to talk about it. We're starting to roll out some changes for doing end-to-end testing on the neutral cloud provider side. So rather than just having, at least from the AWS side, and also I think we're relying on this to some extent from the Kubernetes 6 Karpenter repo. Like as we roll out changes, we want to make sure those things are stable. And right now we're doing a lot of reliance on either the AWS or the Azure provider to determine whether the changes that we make in the Kubernetes 6 Karpenter repo are stable. And we're running it, kind of a full end-to-end test suite against that. We're wanting to shift those things over to make it more neutral and to be able to catch things earlier as we release changes in the upstream repo. So Nick, did you want to talk about that at all?
Yeah, so under the hood it uses kind and clock, so those are both Kubernetes SIGs. projects. And so the idea here is that we would basically have some E2E tests that, use our common E2E stuff in the AWS provider, and we just port it over and removed all the AWS stuff. It's going to basically run some E2E tests and some scale tests, and then output some timestamps, and then he's been helping us here, that view that you had open. It's going to basically, it's like a Python script that's basically going to take those timestamps and then query the Prometheus pod that's in the cluster for all the metrics between those tests, between those timestamps. And so it's going to be super cool because you can use that Python script to, like, if you want to query your own Prometheus metrics within some time frame, like if you're curious about what's happening. Um, but yeah, most of the value add here is going to be that we're going to run scale tests automatically, and get detailed Karpenter metrics about what's happening for each of those scale tests, so that we can be more confident about, like, if we're doing a large provisioning scale test and that's followed by a large deprovisioning scale test, what are the Karpenter metrics for the scale up and the scale down? Yeah, but that should give us a better confidence for merging and changes that allow us to understand what if there's any performance regressions or any sort of scale test things that we should be aware of for each pre-submit.
Yeah. By the way, if anyone wants to take any notes, that's super helpful. I'm adding a few things as we're talking, but feel free to also add updates to the doc as we're talking about each of these things. Yeah, thanks, Nick, for covering that. Yeah, I think we're also, yeah, like Nick said, we're covering this for scale testing. We're hoping to move more of our intent tests over to the neutral code base, so we'll catch things earlier and have like a shorter round trip with the cloud providers that we integrate with. And that's going to be particularly important as more cloud providers on board to the Karpenter framework. We're going to need to obviously have a stronger sense of stability across all the cloud providers rather than just one or two. I don't know if I don't see anyone from Azure here. So if there's no one from Azure here, or if anyone doesn't know about any Azure updates, I'm going to move forward without discussing anything specific about the Azure provider. I think, yeah, I don't know if there was anything that we took notes on last time. Okay. With that, I think the first thing up is the node overlay RFC, which I know Ellis put out. Go ahead and take it away, Ellis.
Yeah, I'm just get my. Well, maybe it's easier if you just screen share, because I'll just pull up the same thing. So this is a trying to make some progress on a problem that's been existing for a long time in the project, which is essentially around how the core scheduler, exposing some of the core assumptions of the scheduler. And today, the scheduler is essentially using a cloud provider as the authority for what all of the different instance types can be to bin pack against. And so that's on a whole bunch of different dimensions of how many resources are available, what labels can be selected on. You guys are familiar with the code base. It's through the instance types struct, essentially. And so the idea there is it's simple, but it's not extensible. So anyone who's trying to influence the scheduling algorithm with respect to price or schedulability or custom resources, if you scroll up, there's a whole bunch of issues that are kind of related to this of customers trying to customize the scheduling, the opinions of the scheduler, essentially. And so I've been trying to figure out, like, is there a way that we can abstract this concept in a really like ergonomic way? Like, is there a way for us to expose this power to customers in a way that is an advanced feature that most people don't need to know about, but if you do need to, start influencing things, like the most basic one is like price, which is this first example here. If you have some, pricing plan, which we can't model today because we don't have the APIs for it, you can kind of inject that price. And what are the dimensions that you would want to inject that type of data. And like you can see below here, like the second example is injecting in smarter devices / fuse, which is another issue that we have. And then there's a third example of changing the amount of memory overhead, which is another issue that we have. So if you know, for example, that you're using a custom OS and that custom OS has a different amount of memory, then you can kind of you can start to influence our kind of base assumptions of the cloud provider around those. You could even you can basically mock out the entire instance type struct. And I don't know if we would support all of this, but you could, for example, start exposing new labels to match against. So one thought I had there was if your organization has like a set of instance types that you want to use, maybe you've qualified them, you know they perform really well with your applications, you could call them recommended instance types, and that label you could inject into a set of instance types, and then you could schedule against them. So an application developer might say, I want to run on a recommended instance type, and then the operations team that's installing Karpenter can say, here are the node overlays for what defines recommended. And that could be used flexibly across different node pools. So there's a fair amount of power here, but I think that the tricky part is how do you do the power and simplicity at the same time? And so the way that I've tried to approach this is with a selector concept and with this overlay concept. So essentially, the mental model for it is that an overlay happens during scheduling, and so we get the cloud provider base opinions of what the instance should be, and you can overlay your changes on top of that theoretical node. So a node overlay is really like a theoretical node overlay, but it will materialize into like the materialized node will be the kind of base cloud provider assumption plus your overlay. And if you've somehow configured daemon sets or the kubelet in such a way that the overlay plus the base is the actual node. And so, yeah, I'm kind of open to other names here. This is the best one I could come up with. And the way that it works is there's a selector, so you can select on arbitrary dimensions of those nodes. So the selector is essentially selecting nodes and overlaying properties into those nodes for our internal scheduler. So for example, here you could say on-demand instance types within all these different M5 types, they have a smarter device fuse. And if you had a set of instance types that had two, you would need to provide another node overlay. There's some interesting semantics here of what do we do if there's collisions. Like it's very easy to imagine that I would want to have a node overlay over here that modifies price for everything, and a node overlay here that exposes custom resources for just a couple of types. And it's kind of tricky we want to make sure that we can merge those correctly. And so I was thinking about kind of another, in that philosophy of like, you don't need to think about it until you need to think about it, introducing a concept of weight so that if you did have collisions and those collisions were material, you could bump the weight up and they would all have a default weight of 0. So you could say this one takes precedence over that one if you had a precedence problem. So that's kind of how I've been thinking about this. I'm currently drafting an RFC just to kind of describe some of the trade-offs that are in here. It seems like there's already a whole bunch of discussion I haven't had a chance to respond to yet. I've been focusing on a couple of things, but I just wanted to get some early feedback from the group on kind of the concept. Yeah, just open the floor to any ideas.
As a question, would it be possible to apply a static fixed like node cost using this overlay system?
Yeah, so you see that price percent 90. This was actually a really interesting question of like the combinatorics of how many overlays you might need and the controls that we could give to collapse those combinatorics. So if you go look at the Go struct, Jonathan, I might have had maybe check this in, node overlay. So I have price percent, and I also have commented out like price adjustment, which is a base price. So say, for example, you're using Datadog and Datadog has a flat price per instance, you could model that in this way. And then we could bin pack against kind of external or like Windows licensing fees or any. Yeah. And so we actually have a fair amount of power. Like this could be, I could write a Turing complete language in here for you to describe the math. Or we could do something like, mx plus b. So you can do a slope and you can do a base and, draw any line you need to, or draw any straight line you need to with that.
Sure.
Whether we would try to do like more complicated curve fitting You can, I'm sure that the pricing deals in the world are more complicated than anyone could hope to model, short of a Turing-complete language. But we have this problem for capacity too. So you say things like, oh, does it have 10 megabytes of memory overhead, or does it have 10%? And so one option is that we actually, I started off modeling this like as one-to-one with the instance type struct, and then I realized that that's actually not even, it's kind of inflexible to do so. Like with price adjustment and price percent, those are two controls for price. And similarly for capacity, you could imagine like a percentage-based one and a flat one. And so I think the goal is to put the minimal set of controls that meets the customer use cases. And so I think those will hopefully emerge over time, and we can kind of introduce new fields as necessary as we think makes sense. And kind of in the classic Karpenter way of doing things, like don't implement it until we absolutely have to at the last moment once we understand the use case.
Cool.
I really
Do you
like
wanna-
this. Sorry to butt in. The company I work for, this would solve two pretty important problems for us. One being about custom resources and being able to tell a node that it hasn't got one GPU, it's actually got 5 GPUs or 10 GPUs because we do GPU slicing. And another, I guess, weird one is being able to, can you add labels? Sounds like you can with this. Being able to select on like an availability zone name and then inject the ID as a label because currently that's not automated.
Didn't we just build support for AZIDs?
Yeah, V037 has support for AZIDs. I mean, when we dropped support for one, or not dropped, when we added support for 130, we also added support for AZIDs within
But
that.
Well, that's amazing.
This is a great question, though. You could inject that. So if you look down at requirements, line 59
This
or
one here.
60. Yeah. So you could have a selector at the top that says US West 2A. Any node with a US West 2A is overlaid with US West 1A or whatever the ID is.
Yeah, in the ID, yeah.
You could totally do that. Yeah. The other thing, and this would require more support, or more code. I was prototyping how hard this would be, but you could even do it like per node class or even by node pool. So you could say like nodes with this node class have these things, or like you could be really prescriptive in that upper selector. So I don't know if there's kind of, I was very curious to see where the use cases would emerge for this requirements bit, and how many of them we could just implement as a first class feature. And I think the guiding philosophy for this, and I need to take a note on this, is like anything that can be built as a first class feature, like should come before it becomes a feature of node overlay. Like we really do want this to be like a last ditch thing. So zone ID is a great example of like we can just support zone ID, and then we don't need to like ideally Karpenter customers just don't need to think about overlays except in the extreme kind of most custom use cases.
I didn't realize 037 added it, but that's really good. We're about to upgrade to it this week, so. The only other thing I was wondering, maybe you've kind of already answered this before, but have you thought about the ability to do math on some of these things and how difficult that would be?
What kind of math?
Like say a node exposes X number of GPUs. Right now, we kind of have node pools where we can cover a number of different node types that have, I think AWS goes up to 4 or 8 per node on GPUs, and just being able to multiply that by a number. So turn 8 into 80, for example, but also turn 1 into 10. That would require multiple overlays in this current design, right?
Well, yeah. So for price, there's a kind of a scalar and a constant. So there's like the price adjustment, which is multiply by the price. You could do the scalar version, then or sorry, price percent is the scalar and price adjustment is the constant. I think you could do a similar thing for capacity. So you could say GPU 200% or something.
Yep.
That would double. And I don't know how we would model it exactly, but yeah, absolutely. Like I think some types of custom resources I think are going to be flat per instance type, and others are going to be like based off of the instance type, in which case you might need a bunch of overlays itself. I don't actually, can you go into the use case of when you might like lie about there actually being two? Is that for a GPU or?
Yeah, very specific. Like it's when you do time slicing, when the device driver loads on, you can tell it to just take whatever number of GPUs is there and then slice each GPU into X number. So if you have 1, you end up with, say, 5. If you have 2, you end up with 10, so on and so forth.
And that exposes as the exact same like nvidia.com/GPU custom resource. It doesn't, it's not like partial GPU or anything.
They do both right now. So it edits the actual nvidia.com/GPU and adds a new label. But Karpenter has no knowledge of that new label.
Yeah, so just explore how this would be implemented in both approaches, because the only like doubling the CPU or doubling the memory just seems kind of hard to imagine that would ever be a thing.
Yeah, for sure.
Some custom resources, maybe like maybe you like could like do a factor on huge pages or something. I don't know if that makes any sense, Jonathan, but we did have an issue about that a while ago, right? We could scale huge pages.
It's based off a different resource though, right? So it's kind of that dependent resource model where it's like you have a memory number and you want a percentage of it to be allocated to huge pages or something like that.
Yeah, so you would like scale the memory down by 10% and the huge pages up by another percent, or yeah, I mean, it does start to get, the second that it's not like multiply this by something or add this to something, and it's like, oh, these two interdependent resources, it gets really hard to model. Or maybe you just have to like code gen your node overlays to get it right.
Yeah, I mean, having to do multiple node overlays is already a massive improvement over not having the option at all. So
yeah.
like it's not a hard ask or anything like that.
One of the original designs, and Jonathan wrote an RFC for this 2 years ago when we were first exploring it, was we kind of have this high level option of, do we model this on a per instance type basis where you have to specify everything about the instance type, and you wouldn't get any of these kind of dynamic multiplier things, but you would have all the control. So you would essentially, all of that dynamism, you would inject via like a code generator, and you would just code gen out the 500 node overlay or whatever node overlays that you needed, one per instance type. This approach like tries to make it like more usable, not require everyone to write a code generator to do all this. But it is kind of interesting to note that the degenerate case of this, if you have a selector for a single instance type, it does support that case, as you could actually have per instance type constants that kind of fully control the scheduling simulation for arbitrary functions. So if you want to have like a very complicated price curve across different instance types, you could model that through many code node overlays.
Yeah, awesome.
And similarly for capacity. The other thing, I guess, is you could even do multiple. You could say instance type in this node pool has that, so you could get even more fine-grained than just single instance type. So I think the selector is like, I'm completely convinced at this point that the selector is the way to go.
Yeah, I agree.
The last thing I'll say on this is my plan to launch is to not launch with it. Those are going to stay commented out, and that I want to do the initial work to allow injection of these things, but probably just do it on price percent, and then kind of allow the community to, as needed, kind of discuss the individual points, because I don't want to have to litigate like, here's the exact price experience that we want, here's the exact capacity experience we want, and I know that's probably disappointing from a custom resources perspective, because I know you have two problems that this would solve, but I think it's going to be the fastest way for us to get this over the line. And then it'll be ideally much easier to add all the other pieces.
Yeah, this is really cool. Thanks very much for putting this together.
You got it. There's a comment from Jeremy Bolster. Can we mock a taint into it? Thinking of auto tainting graviton without having to make a new node pool. That's interesting. We don't model taints in instance types today. We only model taints. I think I'd want to understand why you wanted to auto taint graviton.
Yeah, so
Oh, maybe it's because you don't. I guess maybe you could do a similar thing for Spot. Say, like, I want Spot to be tainted or Graviton to be tainted because I want pods to opt into it.
yeah, exactly. So just having pods opt in, but then not having to create more node pools. Node pools change. Having multiple node pools changes how you do quotas and that sort of thing, right? But
Yeah.
if you have it auto adding taints, then you can keep the one node pool, so you have all your quotas and whatever else.
Yeah. Totally. I think you could do that. It's interesting. We haven't really thought about this use case at all. There is this assumption that if you were trying to do multi-arc node pools, that you have multi-arc containers for anything that might run on that node pool. Yeah, I'd be curious to explore that one. Kind of to the previous tenet of like use node overlay as a last resort. Like if we don't have a better way to solve this in node pool, then node overlay is kind of the fall through. I'd be curious because I think the other thing that I'm thinking about is node overlay isn't actually mutating the node at all. It's mostly just like it assumes that the mutation is done elsewhere. So for example, if there's going to be like a GPU slicing thing, this isn't doing the GPU slicing. This is assuming you have something else that's doing the GPU slicing, and then this is kind of updating the scheduler to respect that GPU slicing. So from the tainting perspective, it would be not like it would change the responsibilities of node overlay to now also mutate things if we were to add tainting in there. So I do wonder if that tainting feature actually we might want to build into node pool proper, or think about.
It's kind of interesting though, because like requirements starts to blur that line because labels get propagated in by requirements. Like if we have a static label associated with a requirement, then you inject that. So
Yeah. No, you're right. You're totally right. Maybe one of the reasons why I didn't want to design requirements yet, because you're right. That's an interesting consideration, especially with our recent conversation about like after the fact labeling everything.
Yeah.
That we can essentially guarantee that that's always there. Anyways, yeah, so that's the idea. I'm hoping to get as soon as I can get some bandwidth to just write down my thoughts. Hopefully by next working group we'll have something more formal.
Cool. Thanks for putting that together, Alice. If anyone has any more thoughts, feel free to add them into the doc. I think we're going to move on at this point. Thorben, I know you're here. Did you want to give out an update on ODCR support, how we're thinking about this?
I've updated the docs based on what we talked about in the last working group. I was super busy with work last week. I'm going to be I have a lot of things today, but I'm going to be free the next 4 days. So I'm planning on making some progress so we can, the next 4 days are booked for this. But yeah, I would guess that I'm going to need like 2 days, and then I'm going to sync up with you guys to see how the current situation looks. But I think we got a pretty clear direction from the last working group meeting of what we wanted to do. So it's more of a matter of time, how much time I have to work on this. But I finished everything, so I hope I can work on it this week.
Yeah, so I'm trying to refresh my memory. I think last time what we said was that we would allow open ODCR selection. I believe open ODCR selection, just based on the way the create fleet handles that kind of selection mechanism. For anyone that isn't familiar with how like well, honestly, it's kind of difficult to understand how Create Fleet understands ODCRs in general. There's like so much modality to the way that it reasons about like the different ways that you can put like different input configuration parameters into the Create Fleet API. But what it boils down to at the end of the day is the only way that we can control whether we get fallback from Create Fleet or not. So there's this whole consideration about whether if I launch with like using the Create Fleet API and I specify ODCRs, do I like without actually opting into on-demand capacity, do I get the ability to say, please don't fall me back. Like I only want the ODCRs to be launched. Don't put me on OD, even if the ODCR, like if the ODCR isn't available, don't put me on OD. Just automatically. Like let me Karpenter decide whether like if I can't get an ODCR, like whether I should fall back to spot or whether I should go to OD or whether I should go to a different node pool entirely. And the only way to guarantee that, at least today, is that you have to statically specify all the ODCRs, like target each of them within different launch templates and then launch with those. And so what that means, practically speaking, is that open ODCRs can't be like blindly specified. Like I can't say I just want to be like Create Fleet basically has an option to say like here's all my instance types, and then blindly select like discover an open ODCR or any open ODCRs in my account, and then from that determine like whether any of those instance types are like matching an ODCR, and then pick that like first, like fill up the open ODCRs first, but I don't have to specify each of the ODCRs. And I think the way that we're thinking about it is that we would target each ODCR that we want to launch into because we have to discover it anyway for our scheduling algorithm. Like we would want to understand open ODCRs for the scheduling algorithm to know that like we should prefer those within scheduling first. And so when we go to launch, we would just target open ODCRs, which is an option. It's kind of a weird option, but if you target open ODCRs, it works very similar to targeting like targeted ODCRs, which is that if you don't succeed to get capacity in either of those ODCRs, you wouldn't fall back automatically. Like you'd basically get an error message that comes back from Fleet, and then you could then like have Karpenter reschedule and try again, or try with Spot or whatever you've specified in your node pool.
Correct, but the idea was that we don't create a new capacity type, right? We keep on demand. The only way that you know how that you're using ODCRs is that your EC2 node class has found some ODCRs, and it will try to prefer them, right? And the default will be that it will be falling back after all the ODCRs are full to on demand for now. And that we are adding a label annotation, I forgot which one it was, with the capacity reservation ID on the node claim if it's a instance that is managed by ODCR, which helps us with the consolidation process, because if you create an open ODCR, your instance might automatically become part of a capacity reservation without Karpenter doing anything. So Karpenter can detect that and just update the label instead of recreating the instance.
Yeah, I think the idea was that I completely agree with what you just said. Like basically that we want to support the use case for users to be able to specify, like, I only want to be in an ODCR. So there should be some ability in your node pool to do selection to say, like, I think the way that we're currently thinking about it is don't create a new capacity type, like you said, just do on demand, but then extend on demand, basically say ODCRs are a subset of on demand, which contain a capacity reservation ID label. And so you can, within your node pool, you can say, give me on demand and require that the capacity reservation ID exists, like that label exists on the node claim, which implies that it will, like you have to use a capacity reservation for that specific node pool because that's part of the requirement set. But the upshot of that is that it doesn't require any application owners that don't care about whether something is capacity reservation or not to have to specify, like, I'm specifically opting into capacity reservations. Because if anyone is like specifying I can only run it on demand today, they would have to basically extend that existing like set of capacity types to capacity reservation as well. And I think we think that we don't want application owners to have to reason about that. So they can continue to specify, I only want to be on demand. The cluster admins who are configuring the node pools, they are the ones that get to.
I mean, they could if they wanted to, right?
They could if they
because
wanted.
Because they could do the same affinity or whatever with saying that they want this label, right?
Yeah.
So they could force it, but they don't by default have to change, right? So if you're starting to use ODCRs, you don't have to change all the applications. Similar use case, I think, with the Graviton, what
Yep.
someone just said, right? Because if, for example, if someone doesn't support Graviton, they should add a label to their node selector and say, I only want to run on ARM or on AMD, right? But they seem to not want the application teams to make changes, so that's why they're asking for that feature.
Yep.
Yeah, I hope I'm gonna get time this week. Yeah, I'm gonna make a lot of time for this week. I promise. Last week was just crazy. So because I want to make progress on this, because we need this. So
Yeah, and I think we agreed. So we're gonna change the terms quite a bit, right? Like I think we're scoping quite a few of these terms down. We'll specify an open or targeted option. I think we'll kind of refine some of this API. It's my understanding as well.
let me think up on that with you. I'm not 100% sure what you mean there, but
I think kind of just like classically in the same vein of what else was just talking about. Like we want to specify the minimal set of options that we expect like users will need, and then we can kind of naturally extend that. But the second that we introduce them, we're kind of stuck having to maintain them, especially since we're about to go V1. Like that's going to necessarily require that we have stable support for the API that we introduce. So if we screw up and we overshoot what we think we need, then we're basically stuck. Like we have to just support it.
Okay, yeah.
Sounds good. Thanks for doing that work, Thorben. I know Garvin was also involved in that. It's really good. I did skip over this one. Nick, did you want to make any additional comment? I know we talked about this last time, but I don't know if you want to make any additional comment based on the existing discussion that's happening here.
Yeah, I wasn't gonna give you a hard time for skipping over it, but yeah, I think there's not too many comments. I would love to hear more, but I think I've heard one argument against this. I don't know if it's here. Might need to scroll down a little bit more. Yeah, it's right here. But I think what I'm trying to understand is if the idea of having graceful expiration, if this is something that's just absolutely critical for things like Kafka or any like really stateful workloads. And if it makes sense if people are modeling these workloads with other workloads in any way, like if they're combining like really stateful workloads with non-stateful workloads in the same node pool. I'm thinking if it is a case that people are doing that and combining them, then maybe forceful expiration as like the only way to do expiration might be a little tough for those use cases. Because I think the only way that like, you don't want to interrupt your stateful applications, because like I think Kafka has some implementation that like if one pod goes down, then other pods also suffer from some performance hits. So yeah, basically I'd like to understand more about this use case of like, can I encapsulate all that I need to with just forceful expiration, and then if like I have a stateful workload, then I don't have any expiration. Is that sufficient? I'm not too sure.
Yeah, could you quickly like summarize, just because I need to get caught up on this, like what the
Yeah.
is?
Yeah, so this RC is about making expiration forceful, which is basically like how currently expiration works is that we will allow node disruption budgets and pods blocking eviction to stop expiration from occurring. So this is really annoying for people who have like batch jobs with do not disrupt that just keep rescheduling onto the same pod, where expiration is more tied to the requirement of like a security requirement, meaning like if my node is up past this long, then I think that my node is, there's some security impact to it. And so the proposal here is to make expiration forceful so that as soon as that node is expired, we kubectl delete the node. And what this does, it sends it to like graceful termination. So we'll respect pod disruption budgets and do not disrupt. And then with something that Matt Groot's doing, which is termination grace period, once the deletion starts, the node will have the termination grace period seconds to clean up. And if it's still cleaning up, meaning like there's a pod that was still blocking eviction, then we would just forcibly delete all the pods. So this is how termination grace period will work, which is like a force max drain time. But forceful expiration is about changing that condition for starting expiration from what it currently is, which is no disruption budgets blocking pod disruption budgets and pod do not disrupt, and also not waiting for pre-spin replacements to just deleting the node outright. And deleting the node outright will provision replacement nodes as soon as we can. But the idea here is so that we can have, so cluster administrators can have a clear case of understanding, like, I have this expiration and I have termination grace period. This is the maximum that my node will live.
Yeah, for this specific use case, what were they wanting graceful expiration for? They just wanted
So I
it
trying
to.
to understand more about, like, if I think so. If you scroll down a little more, there's right here they mentioned Kafka, and kind of understanding that, like, there's not always perfect configuration, but it's mostly about stateful workloads where if you don't have something to control when those happen, then stateful workloads, which might affect other stateful workloads in the cluster, can have a bad impact. But I was thinking that people are probably modeling them in different node pools. So I wonder if there's even a case for having a graceful and forceful within the same node pool, or if having just expiration that's forceful and then no expiration on the stateful node pools makes sense.
Gotcha. Interesting to read through this. Yeah, I mean, I think there was the other point that we talked about, which is that like you can orchestrate. I mean, it's a little bit indirect, but you can orchestrate a graceful like expiration through drift if you wanted. You could write your own controller. You could annotate something, orchestrate it yourself.
Yeah.
It's not first class, obviously, but kind of provides a workaround for anyone that has the use case, unless we think the use case is common enough. But sounds good. I'll quickly run through these because I know we're running short on time. Headroom provisioning request API stuff. I had put together this document that described how we're thinking about headroom, and I'm probably going to rename it to pod headroom. If you're not familiar, I mentioned this at last working group. Cluster Autoscaler basically put out a provisioning request API, I think it was September of last year, and merged it in around that time frame. That provisioning request API supports use cases around like overhead for pods and applications. So pre-spun warm pools for applications, a floor for those applications as well. So if you wanted to pre-provision capacity and always have that capacity around, you could support that. As well as providing ways to, specifically they were addressing cases around atomic scale up. So they're concerned with cases where you want a pre-provision capacity for jobs and you want that to fully succeed before you actually orchestrate the rollout of those jobs onto the capacity. So we thought about this a little bit. We also thought about it in the context of static node provisioning. So this is basically a document that describes, one, how we're thinking about this in terms of API, which is described here. And I think, like I said, I'm going to rename this to pod header most likely, as well as some of the differences between I guess the two different APIs and perhaps how we'd like to reshape the provisioning request API to look a little closer to the way that we're thinking about this problem. I think the end goal with a lot of this like cluster autoscaler Karpenter API alignment is that there's going to be integrations that are going to happen with these autoscalers upstream, and ideally those integrations don't have to happen twice, especially for new APIs that are going to need to be extended. So provisioning request was particularly useful for an integration with queue. I suspect any other batch schedulers are going to care about it, especially if Kube Scheduler eventually supports some sort of atomic scaling or atomic scheduling, so some sort of gang scheduling directly. So ideally we can align these things. We're still doing work with Cluster Autoscaler upstream and having a discussion on this. I'll probably be attending SIG Batch this week to kind of discuss this a little bit more. I'm also planning on doing a POC of some of this work. So be on the lookout for that. That should be coming out relatively soon. I'll just throw a draft up in the repo and hopefully get some more thoughts from people on this. And the V1 RFC is still out. That one's been out for a while. I know that there's been a few comments on it. I need to take another look at it because I know there's been some discussion. There's also a bit of change that's gonna happen here. I think there's some additions that need to be made. I think we may skip add termination grace period in here for the V1 release, and there may be some stuff specific to the database provider that gets added in here as we've been having some discussions internally. But I just wanted to mention that if you have any, or if you haven't seen this, feel free to take a look at it. Please make comments. This is kind of the last ditch effort to raise any concerns if you have issues with the current V1 API proposal before we release V1 and kind of introduce stability. And with that, I don't see any community questions, so I'll kind of give a little bit of time for anyone to ask any outright. Otherwise, we can wrap up for the day. Going once. Going twice. Okay. Thanks everyone for attending. I think there's some good discussion today, and there's a lot of stuff that's happening, so exciting things coming soon. Everyone have a good rest of your day, good week.
Thank you.
Thank you. Bye.